what I've come to call a hyper-optimized design is not always the best solution in my mind. We do need to use our computational tools to optimize, but we also need to get out of the mindset of buildings as single use at a single point in time. And if you hyper-optimize a building as a residential building and you assume that it's reasonably maintained, it will continue to function as a residential building over time, but it will probably not be able to serve another function with potentially higher occupancy type. So you're losing some of the flexibility of a building being able to live several lives and perform different functions over time. This to me is a very interesting thing to think deeply about, and it has more to do with kind of multi-generational buildings as opposed to the building and the challenge that's in front of us now and optimizing it for this time and place.
As you know, I have a very clear mission with Building Green, and I know so many brilliant architects, interior designers, and contractors who do too, but they're still stuck working on projects that drain them with clients who don't value what they bring. That's why we founded Market Your Architecture a year ago. It's a marketing agency that helps mission-driven designers attract better clients, charge what they are worth, and finally build the kind of portfolio that reflects who they really are. If that sounds like the shift you need, there's a link in the description to marketyourarchitecture.com. And before we jump into the podcast, please rate and subscribe. It really helps me reach more people like you. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipp, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. What do trees, poetry, and structural engineering have in common? For Justin Denherder, they're all about connection, efficiency, and reciprocity. As a structural engineer in New York, Justin leads mass timber, sustainability, and computational design practices, constantly rethinking how buildings can better serve people and the planet. From adding timber stories to old concrete buildings to viewing cities as living forests, his work blends creativity with responsibility. In this episode, we explore why mass timber isn't a one-size-fits-all solution, how poetic engineering makes structures more human, and why trees remain the ultimate architects. Justin, I'm really excited to have you on the podcast today. Before we go into all the technicalities and the details, tell me your story. How did you get where you are today?
So I'm a structural engineer, and I'm part of the buildings group at TY Lin, which is an international engineering company and organization. And I work as a structural engineer based here in New York City. And my role at the company involves questioning and considering how we can collaborate better and improve the deliverable quality of what we produce. And that takes many different forms and angles. But in addition to leading projects in an engineering studio here in the New York office, my role company-wide involves supporting and advising our mass timber community of practice, our sustainability community of practice, and our computational design community of practice. So I like to say that I live at the center of the Venn diagram of those three things at this point in my career, and they are wonderfully interrelated. And the reason why I've focused on these aspects is because I've come over the course of my career to understand the impact that our buildings and the built environment has had on the natural environment and the planet at large. And it's really important to me that be part of improving that relationship between those two realms, which are really just one interconnected realm, and find ways to have more reciprocity between the natural world and our sourcing of materials and how we use them creatively, wonderfully to create shelters for human beings. That's my role at present. There's probably 1,000 touch points that lead to why I'm here and why a structural engineer. And if you'll indulge, I'll maybe touch on a few of those. As a young boy, my dad worked at the Department of Public Works for the town that I grew up in. So he was not a licensed civil engineer, actually didn't have a college degree, but he learned on the job as an apprentice, and he worked there for 35 years, doing road resurfacing and drainage design. And he was a draftsman, and he created these beautiful site plans by hand. And in fact, his second job to help make ends meet, I'm the oldest of 6, so we had a pretty large family, and both my parents worked multiple jobs to help make ends meet. And I have this distinct memory of many evenings standing on top of a laundry basket, which I turned upside down, and kind of peeking up over the draftsman table that was in my father's bedroom. And he would work with the lamp and with the old Leroy stencils. And part of just watching that process of him drafting by hand had obviously some kind of impression on me, because if I look at my wall here, I see all my attempts at creating beautiful engineering sketches. So that part stuck with me. And then I was also became very fond of technology and computers. And around probably about 1992, my family saved up enough money, and my dad got a good deal through a friend of a friend who worked at Dell to buy a Dell Pentium P60 computer. And I played and tinkered with that computer quite a bit. And as I conveyed to you before we started recording, at one point I realized that I needed to upgrade the computer's RAM to be able to play this PC game that I was really into at the time, that all my friends were playing. And I have this memory of having taken apart this several $1,000 computer that a lot of blood, sweat, and tears had gone into saving money up for that. And my mom came into my bedroom. The computer was on the floor in pieces, and she gasped. And to her credit, she kept her composure. And she said, "You better have this back together by the time your dad gets home from work." And I sensed the urgency in her voice. I got it back together in time, or at least that's my memory of what happened. And subsequently would upgrade computer from year to year to be able to play the PC games and the programs that I wanted to play. That became my after-school job in middle school and high school. I learned on the job how to deal with computer hardware, but I realized now, more importantly, it was dealing with people and customers who would come into the store who were in a panic. I've lost all my files, or my life's work is on this and I can't access and I don't have a backup. It was that kind of customer service that actually serves me better in my job today, more so than any sort of technical expertise. So as a structural engineer, I am a sub-consultant and in the service industry. I'm in service of our clients and in service of the wonderful projects that we create. So I learned a lot through that, and I actually did that for Manhattan College, where I got my engineering degree. I ran their computer help desk for 3 of the 4 years that I was in college getting my engineering degree. And that helped me offset some of the cost of university here. So that all helped pave the way to me getting an engineering degree and doing what I do today.
That's beautiful. I really like that note of you're in the service industry. I think all engineers, architects, developers, it's something you easily forget. You just focus on being really good at your craft. And in the end, you need to help your clients get their dreams come true and help them with their project. So there's actually one point I really would like to follow up. You mentioned the importance of the connection to the earth and nature. And I saw on your personal website, you have an entire section dedicated to trees. What made you first fall in love with trees so much?
I don't know that I can pinpoint to a specific point in time, but I can speak to my appreciation of trees at the present. And as I first started designing more and more projects with mass timber, and with all forms of wood, but especially mass timber, where we're increasing the volume of wood in our buildings, it became really important to me because you also see these images from around the world in tropical and temperate rainforests where forestry practices have gone wrong, and you see, slash and burn type of approaches, or monocultural tree plantations that aren't healthy, biodiverse regions anymore due to inappropriate human interaction. And it was really important to me that I understood the benefits of mass timber within buildings in creating beautiful, healthy spaces with hopefully clear and transparent supply chains. And the idea that a building could become a carbon sink, a carbon repository, while we grow more trees in the forests that are also extracting more carbon from the atmosphere. It almost seemed too good to be true as a solution. But I was hesitant to immediately become an advocate, right? These days you can't open an engineering or an architecture publication without seeing beautiful mass timber projects. So I was a little bit skeptical of kind of the fashionability. I was afraid that it was just trendy. So I embarked on kind of a personal endeavor to better understand trees and how they work, and to better understand how forests work and what makes a healthy forest, and what are good forestry practices, so that I could, and that's a very complicated answer I'm finding out. And that answer is nuanced and is perhaps slightly different depending on what part of the world you're in and the specifics of the forest and the region that you're harvesting the wood from. But there are some commonalities as to what makes good forestry practice. So it was important to me that I did my own homework and felt comfortable that I could be an advocate for mass timber in buildings, but also an advocate for good forestry practices to make sure that, like I said earlier, that there is reciprocity, not just between the forest and the building, the mass timber building, but also the community and the sawmill and the people who are doing the work of forestry and doing the work of fabricating and working in the sawmill, that it was mutually beneficial to them too. Because what I've come to realize is that our supply chains for many of our common building materials are very fraught with forced labor, child labor, and other obscure supply chain obscure supply chains that really can have and do have negative impacts on large portions of the world.
Do you have 3 or 4 non-negotiables, boxes that you have to tick and otherwise you do not choose mass timber?
What's really important to me and to our firm, what I try and instill within our firm, is that we are looking at each project with fresh eyes and critical thinking, and that we are not saying that there's a one sentence or one particular aspect of sustainability that works for all projects. I think there are things that are better. Mass timber is lower embodied carbon than concrete. So yes, we're going to put forth mass timber over concrete wherever that is a possible feasible solution. But still we're looking at it with a critical eye, because there's more volume of wood within a mass timber building than, say, a stick-built wood building. But it's not as simple as a one-to-one equation. If you use stick-built framing, typically you have to protect it with some kind of fire-rated material like drywall. That has embodied carbon. That has its own supply chain challenges too. So that's what I mean when I say we try and approach each project very critically, with critical thinking, and really try and understand as many parameters as possible, because each project really is unique and has its own challenges and its own thought process that needs to be kind of worked through.
And there's so many people hyping up mass timber, and there are reasons for it. What's the biggest misconception you think people have about it?
The biggest misconception with mass timber, I would actually say, maybe we've touched on it a little bit already, is that it is always the right solution. But that would be one. I think it isn't always the right solution, and there are scales of projects where, stick-built wood framing or other forms of engineered wood that maybe dimensionally aren't categorized as mass timber might still be a totally valid approach and might be less volume of material and could still be a lower embodied carbon solution. So it's important that we do our due diligence and rigor up front to really understand that. I think more broadly speaking, there are rightful concerns related to fire rating and fire resistance and moisture percentage and moisture infiltration. The common, I think, misconception still, even though there's lots and lots of data that provides us with very distinct, very consistent and uniform rates of charring per species of wood. There's much information out there that shows that the rate at which different species of wood burns in a fire event is actually very, very predictable. So I think that the answer there, Ladina, is that although wood is a combustible material, we can design it to perform very predictably in a fire event. And there's lots and lots of testing to support that.
I wanted to ask about New York. New York just recently, or New York City just recently started allowing cross-laminated timber. Why do you think that has taken so long? Does that have to do something with the fire risk?
Yes, it does. And there's probably many other factors too. I think historically, New York has been generally very slow to embrace code updates. We're usually one or two iterations behind the International Building Code, which is the building code, the foundational code upon which New York City's building code is now based. I think a lot of people have strong opinions about that slow rate of adoption for new code techniques. And sometimes I do, but I think it's also very important to remember that population-wise, New York City is twice as large as the next largest city in the United States. It's extremely densely populated, unlike other cities within the United States. And as a result, there are unique considerations here that warrant closer examination and inspection. So I appreciate that aspect of it. By the same token, I would love to see New York embrace mass timber and other forms of lower embodied energy and embodied carbon materials within the built environment. New York City has made some very ambitious commitments as a city to reduce carbon in our city and within our built environment. And we really need to be accelerating our adoption of mass timber to help us meet those targets. So I would love to see the mass timber aspect of the code increase in speed.
And you've worked with a lot of different architects around the world. Are you currently working on a mass timber high rise in New York City?
Not a high rise. So part of where we stand in New York at the moment is that mass timber buildings are limited to type 4 heavy timber construction requirements. So the tallest mass timber building that you can currently permit, I'm just talking about like the most direct path to permitting, not talking about prescriptive approaches or exceptions to the rule. But the tallest mass timber building that you can build in New York is 7 stories, or about 85 feet, which is not very tall. If I crane my neck here and look out the window, I see many tall buildings. Whereas the newest version of the IBC allows for substantially taller mass timber buildings up to 18 stories. And in some jurisdictions, there are other prescriptive routes to build much taller. So we are not there yet in New York. I've had conversations with the building department, and there are people at the building department who are really working hard to make sure that there's thoughtful due diligence being applied to our code to allow us to accept taller buildings here. But at the moment, that's what we're limited to by code. I am working on new ground up mass timber buildings in New York, but they are not taller than 6 stories.
So you don't know of any project where they're working on getting a special permit for maybe not high rise, but for a taller building, mass timber building in New York City?
I am not aware of any at the moment. I know, there are a lot of developers who are interested in designing and building with mass timber, and many of those developers think they can be the one to convince the building department that their project should be the first one. I think it will take a lot of convincing of the building department to do that. Part of this restriction, as I understand it, has to do with rightful concerns by the fire department related to having a combustible material so high up in the air. I don't know if this is how true this is, but my understanding is that the limitation of heavy timber buildings, 6 or 7 stories, 85 feet, correlates with how tall a fire truck ladder can reach. So there is more education and awareness across many different spheres, fire department, commissioner, and leadership included. There's much more education that needs to happen to raise awareness to the point I made earlier about the very predictable behavior of mass timber elements in a fire-related event.
It's actually a good idea. I would like to speak to someone in the fire department also about how things might change with the more usage of drones in case of fires. But I think that's not a topic you're going to cover. So something else that I would like to talk about, when we first spoke, we talked about new construction versus keeping old structures or reusing old structures. Now, from your engineer perspective, you said saving old buildings is most of the times the most sustainable move. Why do you think the industry is still so focused on new construction?
Yeah, this is a particular topic that I'm passionate about. As a firm, TY Lin Building Group has done some of the most ambitious adaptive reuse projects in New York City and beyond. We have offices in multiple cities around the country. So we have a long history of finding clever ways to reuse material within existing buildings. And I am part of that legacy and that reputation, which preceded mass timber within buildings, from all 18 years of my experience. So I'm excited about mass timber because of its relative lightness compared to other structural materials, and the prefabricated nature of mass timber means that it is very well suited for adaptive reuse projects where we are perhaps considering adding 1, 2, 3, or more stories to an existing building. And I've had the challenge of working on several adaptive reuse projects where we have added stories to existing buildings. And one example of an ongoing project that I'm a part of is the Student Center at Amherst College, which we're working on with Herzog Demeron and Sasaki as the local architect of record. And Herzog Demeron is the design architect on the project. We've been part of that project since 2019, when Amherst College developed a new sustainability plan, campus-wide sustainability plan. And they wanted this new student center to be a new mass timber building that would be the kind of the crown jewel or the feather in the cap, so to speak, of the new sustainability plan that they had developed. And we worked with Herzog Demeron, designing many schemes in a short amount of time. During the concept phase, beautiful new ground up mass timber projects. There is an existing cast in place concrete science building on the site, on the proposed site where the new student center was to be. And I was fresh off experience working on some other adaptive reuse projects where we had added stories to existing buildings. And as we were getting to the tail end of that concept design phase, and we're presenting to the project managers for Amherst College prior to a big presentation in front of the board of directors. During one of those meetings, as it became clear that, and there was re-emphasis on having the most sustainable approach for this new student center, I kind of blurted out in that meeting that the most sustainable thing to do would be to actually keep as much of the existing building as possible, and that we would take the new mass timber massing and put it atop the existing building, and that we as structural engineers with a lot of adaptive reuse experience could quickly evaluate the existing structure's capacity to support additional stories in mass timber. And there was a long silence, and then an agreement and an excitement at that concept. So the rest of our concept design phase was spent validating that approach. And we have a computationally based workflow that we've developed that allows us to quickly understand what we've come to call is the found capacity of the existing structure. So every building that we design, especially older buildings, will often have safety factor built in due to variability in load, variability in material fabrication, and variability that can arise during construction too. So there's an inherent safety factor within our structural designs. Our intention was to appropriately use some of that safety factor to account for the weight of additional stories. And the fact that we're using mass timber as a lighter material allowed us to add more square footage atop the existing building while minimizing the amount of existing elements, columns, and footings that we would have to reinforce. And this is kind of a philosophy that we've come to develop where we can apply this computational-based workflow, and that there can be a reciprocity between the design and the configuration of the grid of the stories that we're adding to an existing building, such that we're tailoring that load path to seek out or to follow the elements that have more found capacity within them. So it's actually quite a wonderful design philosophy, and it can result in some exciting findings and some creative designs.
That's so interesting. And I love this story and how it shows kind of the importance of every person that's in the team, that everybody who can like pushes the idea of thinking again about the whole concept and how to make it more sustainable. It's really a cool, inspiring story.
Yeah, I think, often as structural engineers, this hasn't always been the case, but our role is often as a subconsultant to the architect or subconsultant hired directly by the owner. And I think in some cases, structural engineering teams can feel like they are just always responding to a design that's given to them. And I love that project because it was a great example where we could use our creativity and our technical prowess to help propose and lead a design concept. And this project is now in construction. The project successfully topped off. So we've added all the mass timber on top of the existing structure. It's been a very complex design, but it's been a wonderful project. And we have proof of concept now in this built project. There's still a little ways to go, but we've made great progress in construction. And as I look around New York City and other urban centers, I can't help but think of the fact that as we deal with a shortage of housing, and as we think about how we can better reuse existing material, it occurs to me that there's an obvious solution. We need to think about how our codes can be modified to accept 1 and 2 story mass timber additions to existing structures, because I'm willing to bet that the vast majority of existing structures can accept those additional floors. And really, there's no reason why we shouldn't be densifying our urban centers in this way. And actually, there's a beautiful tool that was created by Whitby Wood, a structural engineering firm, along with Mule Studio in the UK, through funding by an organization called Built by Nature. There's a wonderful tool called Octopin, which is a web-based tool that does exactly this. It takes vernacular buildings in Europe and in London, and quickly evaluates how many mass timber stories you could potentially add to one of those vernacular buildings before you have to reinforce the foundations, which is the major cost driver behind the feasibility of how much you can add on top of an existing building. So I want to give that tool a plug because it follows a very similar ethos to what we developed on the Amherst project and what we've done on subsequent projects. And I would love to be an ambassador for that tool, and am in conversations with Kelly Harrison at Whitby Wood, who you should also talk to if you haven't already, about how we can help them expand that tool and that tool's influence.
Just a quick reality check. If you're constantly over-delivering, working around the clock, and still chasing the right kind of projects, you're not alone. I keep meeting architects, interior designers, and contractors in that exact cycle, which is actually why we started Market Your Architecture. We help you reposition your work and get in front of more of the right people, so you can finally choose who you want to work with. If that sounds interesting to you and you want to know more about us, you'll find the link to marketyourarchitecture.com in the description. I wanted to ask you or dig deeper into the reinforcement of the existing building when you add mass timber, or actually whatever you do. Are there more sustainable and less sustainable ways to do that reinforcement?
Yes, the reinforcement strategy depends on the makeup of the existing building, of course. If you have an existing building that is supported on deep foundations relative to shallow foundations, that can be a big difference in cost, and certainly your reinforcement strategy is going to be different too. That is the most costly aspect of having to reinforce an existing structure, because you need to open up a building, you need to perhaps open up the cellar or the existing ground floor structure, excavate, and then do a complicated, encapsulation of the existing footing or expansion of the spread footings footprint. Or you need to drill more piles, perhaps, which is very difficult to do inside of a building. If you need to drill a 100-foot long or 30-meter long pile within a building that has only 12-foot or 3-meter clearance, it's a really costly and surgical process. So we try and avoid that at all costs. Reinforcing of the columns or the vertical elements of the building can take different forms. That could involve, say, encapsulating an existing column in more concrete, or it may involve bolting or welding reinforcement. Or if you have an existing concrete column, could go so far as to like wrapping an existing concrete column in a high tensile material like carbon fiber, which we've also done. But that's very costly to do as well. So those are some of the strategies. Hence why it's really important to understand where there's found capacity in the existing structure and do everything you can to divert the load that you might be adding to the top of the building towards those elements where there's more found capacity.
If we're talking again about mass timber, are there more sustainable joints, connections, more sustainable ways of using the material than others?
Yes, I mean, there are a number of different ways to connect mass timber elements. Often you will see that there are concealed steel connectors, and there are many providers that make really great fastened steel connectors that can fit and be concealed between two mass timber elements, such that the end product looks as though it's just two mass timber pieces kissing each other, and you never know that there's a connection concealed inside of that, which is very exciting. But that is still a connection where shear forces are being transferred across a joint. So the most sustainable approach, actually, I shouldn't even be so certain about that. Here again, you're seeing, like we talked about before, like the importance of critical thinking on the building scale. At a microcosm, you could look at each connection this way. So a more sustainable approach is often a bearing connection, which requires very little steel hardware. So this is kind of just as it sounds. It's maybe a glulam beam or CLT panel sitting on top of a CLT wall or a glulam column, and the load transfers just through the surface contact in bearing. Often that is the most sustainable approach because you avoid the embodied carbon of the steel connector. You might still have some fasteners in that connection, but the flip side of that is that you if you're transferring high loads through a bearing connection, you might need more surface area, more contact area to do that. So as a result, you may have to oversize your wood elements to ensure that you have enough surface area contact. So in the two examples that I provided, you would need to evaluate what the embodied carbon is of potentially having larger wood members and more volume of wood in your elements over against the embodied carbon of potentially having smaller mass timber elements, plus the embodied carbon of the steel hardware that would be concealed inside. So again, it kind of depends on the particulars of the amount of load and the situation that you're confronted with. So it's important to keep that holistic kind of comprehensive thinking.
That's super interesting. And when you use computational tools to make your buildings more sustainable, do they help you with that micro scale as well? With the joints, looking at specific joints and how to compare the embodied carbon material used and everything?
Yes, if we are designing a mass timber overbuild or a new mass timber building, we are using computational tools to refine that design and optimize it as much as possible. Here again, I'd like to expand on that a little bit and also encourage your audience to think critically about this too, because we are a fan of optimization within our designs, but there is also, if I could offer an opposing narrative to that, what I've come to call a hyper optimized design is not always the best solution in my mind. And what I mean by that is that I have worked on many of these adaptive reuse projects that we touched on. These are buildings that are 150, 160 years old. And even though they may have been abandoned for a long time, they still have enough inherent capacity to accept additional loads, and they have enough inherent capacity to have a second life. Serving a different function. So they may have originally been a building that was a storage warehouse that was next to a shipping port and we've worked on many buildings on the New York waterfront here or the Brooklyn waterfront across the way, that we've been able to revitalize because they had inherent load carrying capacity. So you could take a 160-year-old building that has been abandoned for 6 decades. And even though when I first walk into this building, you might see a column has fallen over, or there's holes in the floor, or there's corrosion present everywhere, you can still repair that building and revitalize it and have it serve a new function, and even add stories to it as, say, a commercial or residential building, because it has this inherent robustness from its original use. So I want to tie that back into optimization, because we do need to use our computational tools to optimize, but we also need to get out of the mindset of buildings as single use at a single point in time. And if you hyper optimize a building as a residential building, and you assume that it's reasonably maintained, it will continue to function as a residential building over time, but it will probably not be able to serve another function with potentially higher occupancy type. So you're losing some of the flexibility of a building being able to live several lives and perform different functions over time. This to me is a very interesting thing to think deeply about, and it has more to do with kind of multi-generational buildings as opposed to the building and the challenge that's in front of us now and optimizing it for this time and place. And I don't know that there's a right or wrong answer. We certainly need to think about the material that we put into our buildings very carefully. But we also need to think about it at varying time scales too. And that is really important. You mentioned before one misconception, or you asked about misconceptions related to mass timber buildings. And I think of some of the oldest built structures in the world are wood. So there's this misconception, I feel, that mass timber buildings can't live multi-generational lives, or that they're susceptible to moisture infiltration and will deteriorate over time. And I think we have a lot of historical examples that say the opposite of that actually wood structures are extremely resilient. The most seismic resistant structures in the world are wood buildings built in high seismic zones. That's, I think, when I say thinking critically about, it's a tremendous responsibility to bring a building into the world, to conceive and have it built. It takes a lot of carbon, takes a lot of people's time, and there's inherent risk in that. And I think we need to think very critically and deeply about that responsibility. Just because we can create a digital form very quickly, just because we have parametric design tools to optimize quickly, does not always mean that we should still be building that thing. And that's something that's very important to me to think deeply about.
So you teach a course called Structural Poetics. What does poetic engineering actually look like in practice?
Thank you for asking that question, because it's something that is really, I think, the engine and the inspiration behind how I want to be as a structural engineer. Structural engineering, trees, and poetry, in my mind, are very interconnected. So the course Structural Poetics builds off of the work of David Billington, who's a professor taught at Princeton University. And his book, The Tower and the Bridge, were very influential to me. So I built off his thesis is that is a definition of what makes structural art. So this is a distinctly human designed structure that is elegant, efficient, and economical. Now, I've added 2 E words to define what structural poetics means. So elegant, efficient, economical, equitable, and environmental. So the structural poetics is an ideal that we strive for, maybe never achieve, but it's important that we have something to guide our designs. Structural poetics is the ideal that we can design towards those 3 E words. So it is not just about the form and the efficiency of the form, but it is about how it impacts the environment and who is it for and who is the structure serving. And these 2 things are really important that we add into that equation, because we are using material from the natural environment. And I would argue that many of our built structures only serve a small percentage of our society and not the whole community, which is where the equity component comes in. So why the word poetics? I personally, I love poetry. I write poetry. I read poetry. And I think there's a reason why humanity in general turns to poetry in our most celebratory and in our darkest moments. So I have always been fond of writing poetry, and I've always been very fond and passionate about structural engineering. And during COVID, rather than looking at those 2 things as distinctly different parts of my life, I flipped the question and said, what way are these 2 things similar? Poetry and structural engineering. And the entire thesis of the class came out of trying to answer that question. And I can try to explain it by saying a poet or a poem that works really well is maximizing the effect or the impact of each individual word that makes up a poem. As a structural engineer, I am doing my job poetically or to the best of my ability when I'm maximizing the impact of the load carrying capacity of each element within my structure to serve its purpose, to provide shelter for humans in all the various different ways and forms and functions that we creatively devise. And it was quite a realization and kind of a life-turning and life-affirming question to ask. And as I began to learn more and more about trees and forests, I realized that a tree, and this is answering the question why I love trees so much, trees have evolved over millions of years to be an ideal singular work of architecture. There is no element of a tree that is wasted. There is no excess material. The form is the function, and every aspect of the tree serves its purpose, and there's no waste. There is no better 3D printer on the market than a tree. It's literally creating biomass out of sunshine and water and nutrients that it's extracting from the soil. That's insane. That's insane. If a human were to create something like that, you'd be winning the Nobel Prize for something, right? And then when you think about how an individual tree could be conceived as an idealized work of architecture, that's my conjecture there, that's my thesis statement, then what is a forest then? A forest is a metropolis of trees. And as I've learned more and more about just how miraculous forests are and how interconnected they are, sharing resources through mycorrhizal networks, underground, regardless of species, the many different ways in which trees communicate and share resources with each other, how a healthy, thriving forest is a biodiverse forest. I realized that a forest is already our idealized version of what a city should be. A city is thriving if it's culturally and economically diverse. And if you think about the transportation system, and if you think about the infrastructure, the sewer networks, the telecom networks, we are really just trying to create the idealized city that already exists in the forest if we just paid more attention and understood more intimately just how complex and how miraculous forests are. That plays into the class structural poetics because as designers, we're often focused, and we have been focused for decades, on singular buildings within often urban settings, right? And we need to realize just how interconnected our built environments are. I think you see this recognition happening in the many different architectural firms that now do urban planning also, right? There's a recognition that our worlds and our systems are more interconnected than we even realized. So from a broad perspective, I see buildings becoming more like trees and cities becoming more like forests. And when I walk around my neighborhood in Brooklyn and I see trees in their individual tree pits, I kind of wonder if the trees feel like they've moved out to the suburbs.
Justin, this is such a wonderful story. I'm kind of flashed right now. It's really, really cool how you tie back everything we are doing into what nature is doing and how we can really optimize our how we're not really far from, I don't want to say optimize because you kind of showed me that optimizing is not always the best, but how we can create the best world just looking at nature. It's really nice. And I'm really excited to see more of your work. If our listeners want to follow what you do, where can they find you?
You can certainly check out tylin.com, the buildings group. You can see many of the great projects, mass timber and otherwise, that we work on. You can find me at LinkedIn, Justin Denherter. And I also have a personal website, which at the moment has some structural engineering related stuff and mostly some of my poetry and some poetry videos that, I'm not so good at guitar, but I try and score my own little poetry videos. So if you're interested in poetry, you can check some of those out too.
I actually have to say your personal website, now that I know you a little better, really reflects the person you are, the engineer, the poetic engineer you are. It's a nice website. Thank you very much, Justin, for joining me. It has been really a nice conversation.
Thank you, Ladina. You asked great questions and really glad to be part of your great podcast.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at Ladina Schipf. Thanks.